All right. So, yes. So if we take 180 degrees berekosha and we remove 30 degrees from it, we are left with 150 degrees. So then it means we can write the cos of 150 as the cosine of 180 degrees minus 30. Can you see that? Then what this means is we can reduce the angle. But now remember, if we have the cos, okay, I'll just write these, ne? 180 degrees minus theta, 180 degrees minus theta. These are just for reference, ne? Just so we can remind ourselves, ne? So remember, if we look at sine of 180 degrees minus theta, what's the answer? It's sine theta. And if we look at the cos of 180 degrees minus theta, it's in the second quadrant. So cos is negative, then Rabali negative cos theta. And the same applies for tan of 180 degrees minus theta. That being said, we can take this and refer back here. And this means that we'll have negative cos of 30 degrees. And if we look at special triangle, where we have 60 degrees, 30 degrees, then the cos will be negative root 3 over 2. Yeah. All right. So 45-degree angle. I just wait. Did I not share this Jamboard with you? Let me just share it. Because I thought I shared everything. Oh, okay, it's not shared. Okay. So, yes. So now, okay. Yeah, one other Jamboard now. Eh?
Yeah.
All right. Okay, cool. Then example ya bobedi. The second example that we deal with now is the sine of negative 45 degrees. Remember my one related negative angles, I get. Remember that. And rare negative angles are angles that we measure clockwise, but they're negative because we, instead of going counterclockwise, which is how positive is defined, then negative in our current maths, then negative is when you go clockwise, which is this direction. So sine of negative 45, it will gonna negative sine 45 degrees. And egamo cosine and its associated trigonometric ratios, including secant, positive. Any negative angle. Then if we look at our special triangle, the sine of 45 degrees is opposite over hypotenuse, and that's negative 1 over square root of 2. These kinds of problems are very low-hanging fruit. So if we master, then it means you'll be able to get those marks, 2 marks, 3 marks in the paper. But those 2 marks, 3 marks, you can get them. At least, I want to boost again to get even a distinction, you know. Yeah, so because those 2 marks are too short. But if it's about the D, You don't have to focus on them, but they will definitely definitely you'll be able to get some marks anywhere in the paper. Right. Then the next problem, okay, the tangent of 480 degrees. I just want to give you a heads up. We're going to do 2 operations star reduction. So this one is typically a 4 mark question. 3-4 marks. I guess you can see more. The last 2 that we did, give 2 marks each. Then Telange 3 marks. Alright. And that's because at some point we reduce the angle, and then at some point we reduce the reduced angle. Alright. So 480, let's think about it. If Richia 480 degrees, ne? And then Ritosha 120 degrees. How much do we get? Calculator, 360, ne? So then we can do the same, or rather we can use that information to reduce this angle. So we're gonna 360 degrees plus 120 degrees. Whatever. Then it reduces us to tan of 120 degrees. Because 360 degrees plus, I get it really on the x-axis, it's 0 degrees and it's 360 degrees. So if we say 360 degrees plus, it's somewhere this side. Ne? So this is 360 degrees plus theta. It's somewhere this side in the first quadrant. So that's the first reduction. The second reduction, we take the same 120 degrees. And then let's think about it. If we take the 180, what's the answer? It's 120 degrees. Then we can use that 120 degrees and write it as 180 degrees minus 60. And this gives us a tan of 180 degrees minus 60. And 60 is in this quadrant. 180 degrees minus 60 is in the second quadrant where sine is positive. And that means tan in negative. So we're going to have negative tan of 60 degrees. Then if we go to special triangles, tangent of 60 degrees ki root 3 over 1, opposite over adjacent, then this equals negative the square root of 3. And for that, you will get 3 marks. So far,
Yeah.
All right. I wonder why everyone isn't joining. That's all right. Then the next, co-functions. Co-functions, right. If we level even a special triangle, ne? Let's do 30, 60 and 90. And we'll also do 45, 45, 90. These are simple, obvious cases. Then we're going to do a general triangle. Ne? Our general triangle, itaba 90 degrees mola, ewa alpha mo kibeba beta, which is 90 degrees minus alpha. Ne? Now, cofunctions. Okay, just give me 2 seconds and a few seconds. I just need to go for a comfort break. Ne? I'm coming back.
Okay.
Yeah, I had too many things to drink in the morning because I'm busy detoxing. Yeah, just got it. All right, Kiwile. So now, our generic triangular unknown angle sizes except 1 year 90 degrees. Return over this side A, then we'll call this side B, and then hypotenuse another which is C. Ne? So Moki. Actually, let me just erase these. Start one triangle per slide, yeah. So we'll start with 30, 60, 90. So let's take 30 degrees and then 60 degrees, ne? Sine. Ne? Oh, hi Magdalene, welcome. Yes, so Magdalene, are you able to see Jamboard? Magdalene?
Huh?
You are able to see Jamboard again?
Yeah.
Okay, today I'm sharing the screen, yeah, the learning guide. Can you see that?
Yeah.
Alright, so Mawani, what we did, we discussed these types of problems. You remember where we reduced the angles from 180 minus 180 plus 360 minus 360 plus to that angle and its corresponding trig ratio with the signs changing depending on the case. I get it? So the next thing I'll do after that, ne, it's a bit grade 12, but I think it will help you to know it because the nice thing about it is that it remains the case whether you're in grade 10, 11, or 12 anyway. So you might as well get exposed to it. Right? So what we're going to talk about is the co-function. So there are problems that if you solve, you'll be looking at the sine of 90 degrees plus something, and then I'll check our answer book. They'll say it changes from sine to cos. Now there's a reason for that, and we're going to explore that reason. For any right angled triangle, not just any triangle, right angled triangle. If we look at the sine for this particular triangle, triangular rinaki 30, 60, 90. The sine of 30 degrees. What is the answer there? Sine of 30 degrees. What is the answer? Anyone? Get 1 over 2, ne? And then the sine of 60 degrees.
Still 1 over. Oh.
Sine. 60 degrees.
It's root of 3 over 2.
Root of 3 over 2, correct. Magdalene, you can also participate, ne? Unless signal is sharp. Ne? Yeah. So, yeah. And then we look at the cos. So, cos of 30 degrees, you're not going to
Root of 3 over 2.
root of 3 over 2. And then cos of 60 degrees.
It's a half.
It's a half. Okay. And then for tan,
It's root of 3. Oh, 3 times 6.
10.
Root of 3 over 3.
So tan 30, ke bokae?
Root of 3 over 3.
For 30 degrees, ne? Remember tan ke opposite over adjacent. For 30 degrees, opposite ke man?
It's 3. Root of 3.
Let's level. On a angle ke 30 degrees again. The side that is opposite the 30-degree angle give.
Oh, 1.
You 1 again. And the side adjacent next to it.
It's root of 3.
Root of 3. So opposite over adjacent becomes 1 over square root 3 again. Then for 60 degrees, opposite side ke, which side?
It's root of 3.
The opposite side is square root of 3, 100%. And then the adjacent side?
Is 1.
It's 1. Okay. So, we can do the same exercise for a 45-degree angle, triangle. 1 square root of 2. These sizes of the sides, the lengths of the sides, you can work them out using Pythagoras. So, Pythagoras theorem. And in this triangle, we assume that x equals 1 and y equals 1. And in this triangle, we cut in half an equilateral triangle of sides Jawabali 2 units each. Ne? Then this side we work out using Pythagoras. So far, yeah, alright. Now, we're gonna do the same. So another 45 degrees, Yamatomo, which I guess is gonna 90 degrees, minus 45. And I guess the other, or maybe I shouldn't use this one. This is a bit, I finally got the idea. So I'm gonna remove this one. I'm just gonna draw a normal triangle whose sides lengths we don't know, but also who the two angles that are not 90 degrees size we don't know. So we'll call this angle beta, and it'll have 90 degrees minus alpha, and alpha kill 90 degree. This side we will call A, this side we will call B, and this side we will call C, the hypotenuse. Yeah? Then the next thing that we can do is look at alpha, which is 90 degrees minus beta, and we can look at beta, which is 90 degrees minus alpha. So I'm doing this intentional because I'm writing these angles kamho intentional, ne? Like this, intentionally, because I want you to see how you just need to look at this angle and know that its cofunction is going to be based on that angle, and you need to look at this angle and know that its cofunction is based on this angle. So alpha, yonaki 90 degrees minus alpha. So we'll start with sine, and we'll define a sine in terms of alpha. Ne? So the angle alpha, sine is opposite over hypotenuse. So if sine is opposite over hypotenuse, then based on the angle alpha, how do we define it using the lengths of these sides? What's the sine of alpha? Opposite over hypotenuse, which side? Anyone? Or is my thing mute?
Opposite B.
Opposite ki B here. No, for alpha. For the angle alpha. Scalibella, the one I drew here, ne? Oh, I see why or ki B. Olivelechi, the one in the screen share, ne? Ne? Okay. Okay, it's fine. We're focusing on this one, Yamo Jamboard. So on slide 2 of Jamboard, it's the same concept as the one in our learning guide, Ege Shirling, on the screen. It's the same idea. They just numbered the things differently, but the idea is the same. So, again, if angular alpha in Jamboard is this angle here, then which side is opposite alpha? It's A, ne? That's correct. Then the hypotenuse is C, again. So that means our sine, it will be A divided by C for the angle alpha. Alright, then what about the angle beta? The side opposite angle beta, gima? Give B. Ne? The side opposite angle beta give B. and the hypotenuse still remains C. So that means for angle beta, sine it over B over C. Then we look at cos. For cos, we do the same. Then if we look at the angle alpha, cos alpha, it will be adjacent over hypotenuse. Which side is adjacent angle alpha?
B.
B, and the hypotenuse remains the same. So the cosine of alpha is B over C. And then if we look at the angle beta, the side adjacent beta A, then the cosine of beta it will be A over C. And then lastly, if we take tan, for alpha, opposite is A, adjacent is B. So tan is opposite over adjacent, so it will simply be A over B. And for beta, adjacent, opposite is B, adjacent is A. Then tan is opposite over adjacent, so it will be B over A. So why are we doing all this mental gymnastics? Is because I'm gonna use, for sine, I'll use blue. For cos, I'll use green. No, let me not do that. Let me do this instead. So, sine 30 degrees, cos of 60. And cos of 30 degrees, sine of 60. So that's the whole basis of cofunction. So cofunction, are these trig ratios different by 90 degrees? And I've said this in 1 or 2 lessons before. When you look at the relationship, sine and cos, differ 90 degrees. Like the relationship has to do with a difference of 90 degrees between the angles. So in other words, the trig ratios of angles that add up to 90 degrees are called cofunctions. So because 60 plus 30 degrees or alpha plus beta give us 90 degrees, then their respective trig ratios are cofunctions. And now what happens, whenever we have a situation where we are looking at the sine of alpha, we can simply say that it also equals the cosine of 90 degrees minus alpha. So if we have the sine of alpha in this triangle, again, the same triangle, A, B, C. So I'll just erase these so they look neat. Yeah, B is the adjacent to alpha. All right, cool. BA. So, sine alpha, elegantly A over C, but it also equals the cosine of 90 degrees minus alpha. That's what the statement is saying. Again, cos alpha, elegantly B over C, and it equals the sine of 90 degrees minus alpha. Alright? And these cofunctions, we limit them only to sine and cos, because tan, if we look at its cofunction, it's actually the cotangent. So we're not gonna do that right now, but it's just good to know it. It's just good to know it.
Yes.
All right. Now, moving along the co-function, there are certain things we need to take note of that have to do with the quadrants. Remember, cosine, all trig ratios, sine, and tan. Now, which quadrant is which one positive? So that's quadrant 1, 2, 3, and 4. Ne? Quadrant 1, 2, 3, and 4. Now, if we have an angle theta moki, and we add 90 degrees to it, we are going to find ourselves in this quadrant here. And since we know that sine of 90 degrees minus alpha, or rather, let me put theta here. The cos of theta. And then what happens, when we have sine of 90 degrees plus theta, if we reduce it, it still gives us cos of theta. Why does it give us cos of theta? It gives us the cos of theta a positive because the original trig expression was sine, and we look at that trig ratio's positivity or negativity based on the quadrant. So remember, trig ratio is sine. The angle is 90 degrees plus its second quadrant. Sine is positive. Therefore, its co-function when we reduce the angle should be positive. So always when we reduce, we look at the original trig ratio for co-functions. We look at the original trig ratio. All right. Then what happens is that conclusion. Now there are other co-function angles, like this one is a negative angle, theta minus 90 degrees. It's a negative angle because if we take 90 degrees minus theta and we multiply it by a negative, that's our angle. Then this gives us negative 90 degrees minus theta, or rather plus theta, and this simply results in theta minus 90 degrees. So it's a negative angle. Now with negative angles, we know that it's only the cos that will be positive. So if, for an example, this starts out as cos of 90 degrees minus theta, then the co-functional one is going to be positive. Co-functional one is going to be positive. So, since the sine is of a negative angle is negative sine, then this is going to be the sine of a negative angle. This is going to be the sine of a negative angle, which is theta minus 90. Sorry, not. Remember I said the negative, so 90 degrees minus theta. Yes, that's what's going to happen. Then when we work out the sine of a negative angle, that's quadrant 4. This gives us sine of, or rather negative sine of the angle 90 degrees minus theta. And this simply gives us negative cos of theta. So the original quadrant, in the original trig ratio is sine, and we're dealing with a negative angle. So if that's a negative angle, then the cofunction should be negative. Alright, one. Now we're gonna do for cos, since the cofunctions are only limited to sine and cos. Well, not only limited, but we mostly deal with sine and cos. So if we look at cos of 90 degrees minus theta, this is gonna be sine of theta, because 90 degrees minus theta is in the first quadrant, therefore the cofunction will be negative. If the cos of 90 degrees plus theta, that's the second quadrant, and in the second quadrant, cos, which is the original trig ratio, is negative, then it means a result, negative sine theta. And if we deal with a negative angle, so the cos of theta minus 90 degrees, then this is going to be the cos of negative into 90 degrees minus theta, and this gives us negative, or rather, this gives us plus cos of 90 degrees minus theta, because a negative, the cos of a negative angle is the cos of that angle. It's a positive answer. And this gives us plus sine theta, because the original trig ratio is positive in the respective quadrant. So these important rules, Musa, you'll always get them on page 203 of Mind the Gap. So page 203 of Mind the Gap, grade 12. So again, Magdalene, you can just pay attention to these ones at the trig ratio. You'll at least get an idea now. How far in high school do we take this thing reduction formula? So I started this because we pretty much had finished with what's this? 180 minus, 180 plus, 360 minus, and 360 plus. That one. I want to expand on negative angles, since Tomilega cosine and sine as co-functions of each other. And I want to do that because if we don't understand how these angles change sine, it will be difficult to come up with these conclusions. So I want Musa to get an idea of how that works, because it will help her a lot with her exam. We're still together, yeah? Oh, Magdalene left. Shame, signal I'm so good, right? So bad.
And then I got 10 past 11 you took hard.
Why?
Detail our area, like even to which you are like if you do so. My
Oh, okay. That's fine. I'll just leave the call on until 12, eh? So you can just jump in and off, on and off, when it's necessary. Alright, so ke sa tswela pele ka negative angles. Right, so we've got the obvious one, which is negative theta. It's in the fourth quadrant. So, sine of this negative angle, when we reduce it, becomes negative sine theta. Cos of the negative angle, cos is positive in the fourth quadrant, then it's cos theta. And tan, which is negative in the fourth quadrant, gives us negative tan theta. And this one you can also think about it from a perspective, tan theta as a quotient identity. So basically, it's the sine of negative theta over the cos of negative theta. So we have negative sine theta over cos theta, and this is negative tan theta. Both ways they work. That's the first case. The second case, that angle 180 degrees minus theta ile theta, or rather let me do the whole thing. Negative 180 plus theta, which is theta minus 180. So this is also fourth quadrant. So if we have a compound angle like this, then when we reduce it for sine of theta minus 180 degrees, it becomes negative sine theta. If we have the cos of theta minus 180 degrees, it becomes the cos of theta, because that's a fourth quadrant angle and cos is positive. And lastly, for tan, then the tan of theta minus 180 degrees, it will gonna lay negative tan theta. Another angle, negative theta minus 180 degrees, and it's in the second quadrant. Hold up. Ooh. I think I may have been misleading you here. Right, negative 180. Sorry, theta minus 180 is not fourth quadrant. It's actually a third quadrant. Why is it como third quadrant? That is because if we have our axis like this and theta shilene, then we take theta and we subtract 180 degrees. We're gonna land somewhere there. That's what that means. That being said, it means the cos is therefore negative, but the tan is instead positive. So please correct that in your notes if you're writing any. But yeah. Okay, I guess that's it.